Hi, I'm Joe Prusa, the founder of Prusa Research. I would love to introduce our new Prusa Pro HT90, the most affordable industrial 3D printer on the market. With a single device, you can produce ultra-fast prototypes from basic materials, get the best performance from advanced materials like ABS, polyamides, polycarbonate, and even print final products from high-performance materials such as PEEK, PEG, PEI, and polysulfones. I truly believe this is the only printer an engineer needs. With our original Prusa printers, our goal was to democratize desktop 3D printing. What was once the domain of specialized industry is now accessible to the general public. With the HT90, we aim to do the same for industrial 3D printing.
Hi, I'm Wojciech Tambor, the head of Industrial Delta Division at Prusa Research. With the HT90, we combine the advantages of a Delta design, high-speed printing, a heated chamber, and we developed a unique cooling system to create ultimate industrial 3D printer for advanced materials. Our innovative servo flap can redirect airflow to precise areas of the models within milliseconds, enabling flawless overhangs with minimal supports. At the same time, it prevents overcooling of the rest of the model, preserving the polymer's optimal mechanical properties and superior performance. High flow and high temperature swappable print heads allow for rapid and versatile printing of pretty much any polymer on the market. A HEPA filter ensures a safe environment for the user. The HT90 is also optimized for printing flexible materials, making it a versatile solution for a wide range of applications. The HT90 is easy to set up and it integrates seamlessly into the Prusa ecosystem with secure remote management via Prusa Connect and advanced model processing in Prusa Slicer. While it offers extensive connectivity options, it is also fully functional in an offline environment, if required for safety reasons. Now let's take a look at some examples of how the HT90 is being used in the industry.
We are at Volkswagen in Emden, in the academy where up to 400 people undergo various types of training. This also includes working in our 3D printing farm. In the 3D printing farm, we produce parts for car manufacturing, the so-called operational material that we need to make the cars. Two things are equally important to me: that the print is always functional and also that the 3D printer is easy to understand and user-friendly. The advantage of this printer is that it is manufactured to industrial quality. I can put it on my desk, I can leave it here in the workshop, and I am confident that it will always produce the parts the way I want them made. The HT90 is very easy to use and super fast. We can print a kilogram of filament in under 8 hours, which is a huge advantage. Sometimes we get a task that needs to be done really fast, and the HT90 can handle it. I really want to emphasize how easy it is to run this printer. You can get started right away and operate it immediately, and there are many options for using different materials. Not only the standard materials, but also high-end filaments. Here is a TPU object printed with this printer, and there are absolutely no difficulties printing with TPU.
We are using the 3D printing in a hospital. One of the most common problems we are trying to solve in our hospital is to do the 3D print modeler in time. With the normal 3D printers we have used before, it takes us up to 2 to 3 hours for a modeler. Together with the virtual prototyping, let's say 4 hours together. And with the new printer, you can do it within, let's say, 1 hour, 1 hour and a half maximally. So it means that you can give your modeler, you can give your 3D modeler to the surgeon in time.
In our series production, we print parts that go directly into the aircraft. Mostly, these are small items. We use the HT90 printer and also the Prusa XL for prototype models and large fixtures. I was very surprised by the speed of the HT90 printer. A fixture that I sliced for the Mark IV was estimated for 24 hours, and the HT90 can do it in just 8 hours. We mainly print with ABS and some critical parts with nylon. High-temperature materials like ULTEM will advance us further, especially in areas where we have high-temperature requirements and where significant mechanical strength is required. These are usually parts for the engine compartment.